Let's take some derivatives of exponential functions. If y equals e to the power of x, then dy dx is equal to e to the power of x. And just as a quick reminder, remember that e is an irrational number, and it's approximately equal to 2.71. Example 1 says, find dy dx if y equals 5 times e to the power of x times the quantity 2x squared minus x. So dy dx is equal to, we're going to have to use the product rule. So we have 5 e to the x times the derivative of the second. So that's going to be 4x minus 1 plus the second times the derivative of the first. And the derivative of 5e to the x power is just 5e to the x power. Let's see if we can simplify that a little bit. So both of these terms have 5e to the x. I'm going to factor out 5e to the x, and then we'd have 4x minus 1 plus 2x squared minus x left over, and that we can combine some like terms. So we should get 2x squared plus 3x minus 1. And I'm going to box that to be our final derivative. If y equals e to the u, then dy dx is equal to e to the u times du dx. Example 2 says find the derivative of the functions below. Part A says f of x is equal to e to the power of 3x squared minus x plus 1. So f prime of x will equal e to the 3x squared minus x plus 1 times the derivative of the exponent, which will be 6x minus 1. So here we are going to need to use product rule. So we can separate this into the first function 8x and then the e to the exponent part. So we have first times the derivative of the second. And we need to use chain rule, so that's going to be negative 12x squared plus the second times the derivative of the first. Let's clean that up a little bit. So if I distribute in the 8x, or not distribute, sorry, if I'm going to multiply it to this term, since this is a multiplication, so that would be negative 96x cubed times e to the negative 4x cubed plus 8e to the negative 4x cubed. So that is my final derivative. Always want to box our final answers. And then for part C, f prime of t is going to equal, before we take the derivative of that, we can actually rewrite f of t because e and the natural log are inverse functions of each other, and so they undo each other, kind of like if you had, for example, the square root of t squared. The square root and then the squared are inverse functions of each other, and so they kind of undo each other, and this just ends up equaling t. Similarly, e and natural log kind of undo each other, or sometimes people will say cancel each other out. And so this can be rewritten as just t to the 7th power. So that, we can use power rule on, so it would be 7t to the 6th power. Example 3 says, Mr. Kwan is saving up for a trip to Mykonos so he can try to spot Lindsay Lohan. He opens up a savings account and puts in $400 that gets 7% continuously compounded interest. At what rate is the money in the savings account growing at the end of 1 year? What about at the end of 8 years? So the fact that it says at what rate is the money in the savings account growing, that should indicate to you, since we're talking about a rate, that we are going to compute a derivative. Now, when you're talking about continuously compounded interest, this is something that is supposed to be review from either pre-calculus or a college algebra class, and we need to make our function first. So I'm going to call it f of t is equal to, the formula for continuously compounded interest is p times e to the rt power. And I give my students just a mnemonic device to remember this. If you didn't know, Pert is a brand of shampoo. And continuously compounded interest means that you are getting interest all the time, even in the shower when you are using your Pert shampoo. So it's kind of corny, but that's how I remember it. Now, what is P? P is the principal amount or the starting amount. And R is your interest rate. And then T represents time in years. Okay, so let's plug in the values that's specific to this problem. So the initial amount, P, is going to be 400, E, and then our interest rate is 7%, so we'd write that as 0.07, and then T, since it's a function of time. Now we can take the derivative, so we have f prime of t is equal to 400 e to the 0.07t, and then we would need to multiply it by the derivative of the exponent, which is going to be 0.07. So f prime of t is equal to 28 e to the 0.07t power. Now, it wants us to figure out how fast or what the rate is when we complete 1 year versus at the end of 8 years. So we want to evaluate f prime of 1 and f prime of 8 to answer those questions. And f prime of 1 is equal to 28e to the 0.07 power. And f prime of 8 is equal to 28e to the 0.07 times 8 power. And I went ahead and plugged those into my calculator, and f prime of 1 is approximately $30.03, and f prime of 8 is equal to approximately $49.02. Now, it's important for us to be able to make sense of what these numbers mean. So f prime of 1 means that approximately the next year, the savings account will grow about $30.03. And then after the 8th year, the amount in the savings account will grow approximately by $49.02. So that's what those values mean.